Alright, we're going to take a look at series in this 8-2 group of videos. And a series is just an indicated sum of the terms of a sequence. Now that sequence could be finite or infinite. So we've talked a lot about sequences. So now 8-2 we're going to talk about a series, which means we're going to take the sum. Alright, so when you see something about a series, it's automatically wanting you to sum things up. So let's take a look at, we know that this is sigma notation. We've looked at how to write it in the previous video. And this just means that we're going to start with I as 1 and we're going to stop when I is 5. So find the sum in each case. So let's take a look. When I is 1, then this looks like this. Raise to the first power. Then I have times 3, 1 minus 1. And so, well, I'm going to go ahead and do this. This will be a sub 1. I'm going to go ahead and write it that way. There we go. So when I is 1, we're on the first term, which is a sub 1. And then we'll go ahead and simplify. So we have negative 1. And then that's 3 to the 0 power, and that's times. So we have a sub 1 is negative 1 times 3 to the 0. 3 to the 0 is always, or anything to the 0 is 1, so a sub 1 is negative 1. Okay, let's take a look at the next one. A sub 2. We take negative 1 and raise it now to the second power, multiply by 3 to the 2 minus 1 power. So a sub 2 is, this time it's going to change that to a positive 1, and then we're going to have 3 to the first power, and so a sub 2 is 3. Alright, moving right along. We're going to stop when we get to 5, when we've used a 5 as the n. Okay? Alright, so we have negative 1 to the third power times 3 to the 3 minus 1 power. So we have a sub 3. It's going to stay negative. You can see the pattern, right? Of course you can see it. So then we have negative 1 times 9, and we have negative 9. Okay, let's take a look at a sub 4. So we have negative 1 to the 4th. You know that's going to clear out the negative. We're going to have 3 to the 4 minus 1 power. Oops, that's a 1. So we have a sub 4 is just going to be 3 to the third power, which is 27. Okay, so let's just highlight the values of each term, the values of the terms. We're not quite finished. I need to go ahead and do one more. So I'm going to go ahead and take a sub 5. And that's negative 1 to the 5th times that 3, 5 minus 1. So I have a sub 5 is, it's going to stay a negative. That's 3 to the 4th power. 3 to the 2nd power is 9 times 9 is 81. Okay, let me highlight that one. Now, this right here means that I'm to add them together. So I'm going to take a negative 1 and add it to 3 plus negative 9 plus 27 plus negative 81. And I get, oops, hello, come on pen. And I get, for the sum, I get negative 61. Okay, there it is. Let's take a look at another one. All right, now, we don't have to start with 1. And by the way, this right here, this I, that's called the index. This time the index is n, and you can call it anything you want. You put any variable there, but we're going to start with 3, and we're going to stop when we use 6, not when we have 6 of them. Okay, so that's a common mistake as well. So when n is 3, this is what it'll look like. 3 times 3 plus 2. And that's going to give me 11. When n is 4, we're going to have, and that's going to be 14. And when n is 5, 17. And when n is 6, that's when we stop. And That's 20. We're going to add them all up, and we get 62. Okay, there it is. Now, this is really interesting. We're going to finish with this example. The first term in this one is 6. The second term in this one is 6. So when I is 1, that's I is 1 here, and this is I is 2. So they want us to stop when I is 7. So there's 3, the 4, the 5, the 6, and the 7. So basically what they're wanting me to do is just add all those up, 7 of them. So when I'm just adding 6 7 times, and we know that multiplication is repeated addition, so we're just going to get a 42. So that's really interesting. You look at that, there's no place to put I as 1. In other words, it's not like there's 6 I sitting there. So we just take it and we're going to use it as the actual value of the term from 1 to 7. Okie doke. All right, hope this was helpful. Thanks for watching.